All right, hi everybody. Welcome to our first video tutorial demonstration. Today I'm going to give you a quick, brief outline of linear perspective. You see here just a handful of books that are in my collection. I'm a big fan of collecting actually hard copy documentation and of art books generally. This one is probably the first documentation of linear perspective, which was invented by the Italian architect Brunelleschi back in 1415. This is maybe put together about 20 years later. And even though it says it's a treatise on painting, it really is more of an obsession on linear perspective. But this is good to know in the sense that in terms of thinking about linear perspective as an invention, what you are doing here is not necessarily representing accurately the world outside of ourselves or as we see it, at least initially anyway. Try to think of it as what we're doing maybe is building a little model or a little version of the world. A number of other really great books. There's things like this. There's a lot of books like this out there, which are some very basic outlines of how to operate with isometrics and things. This may be a fairly familiar image of the railroad tracks and the fence and the telephone poles receding off into a distance. Those images are good references as to what we will be thinking about and talking about today. This is one of my all-time favorites, and I would highly recommend getting this. Vicomte Cole. It's probably around somewhere in the early 20th century, and it's got really beautiful illustrations, and it's got some interesting little techniques and tricks about how to resolve certain problems. Boats, if you're interested, stairs, elevations, even animals in some cases. I would highly recommend this. And then this, I don't know, I picked this up in a secondhand store. It's pretty dated in terms of its look and its aesthetic. It's very late 50s, maybe early 60s, but the information here is really great, and it's for it was for industrial designers. So something like that would be worth looking for. Things a little more esoteric. People like Panofsky, who goes more in depth into psychology of the transformation from early days of when perspective was basically invented, which is largely about Brunelleschi, in this case, discovering that everything converges to one point right in the center, which is your vanishing point, rather than it being all over the place. What I'm hoping is that we're going to do a PowerPoint, and we'll discuss kind of a very basic history of this as well, and just give examples. So what I've got going on here is I've started with 1-inch squares. I've got a central vertical going up. These 1-inch squares, I mean, I think to start with are somewhat arbitrary. I did, I believe, 9 to 10 squares out. And I need you guys to be as precise as you can, even though this is an introductory fundamental drawing version for artists. It can get a lot more heavier mathematical, but I'm not going to go there. I don't think that's necessarily useful to start with at the fundamental level. But I would say try to be as accurate as you can for measurements. So this is essentially 1 inch here by 1 inch here, okay? So try to be as regular with this as you can. Don't start changing these distances even a slight bit, because all of those incremental differences start to add up pretty quickly as we start to move ahead with what we're doing here. So we're going to call this our ground plane here. Line up your squares on the bottom. This is going to be your horizon line. And what the horizon line effectively represents is where your eye rests. So let's call this your eye. Right? He's thinking very hard. Okay, right? So that is eye level. It's as though an arrow is shooting straight out of your eye, off into the horizon, and straight towards what we're going to call the vanishing point in this case. So we're talking about 1 point perspective. Later on, we're going to do 2 point perspective. And if we have time and if we get a decent grasp on these, maybe I'll, at least in a rudimentary sense, I'll discuss 3 point perspective. But these two are the ones that I really want you to focus on and that I'm particularly concerned about you getting a handle on. All right, so the next step, remember to keep this vertical. This should be precise as well. I don't want to see it tilting in either direction. Maybe the easiest way to do that will be to measure from the edge of your page into a halfway point. I'm using my 18 by 24 page. I want a pretty decent sized piece of paper. Measure from here 18 inches in, or what did I do? Not 18. I got somewhere halfway. It's not 18, excuse me. 12 inches in, something like that will work. It's 24. And then I made another measurement this way. So the whole point being try to get as accurately vertical as you can. This is another tool I'm using, whether you have a right angle or not. I know it wasn't necessarily expected in the syllabus, but this is extremely helpful, and of course this is extremely helpful. And we will proceed with that. So once you get your vertical in and your horizontal horizon line, which is where you are situated. Your eye is situated along the horizon line. Then bisect each of these first 2 boxes that are making contact with the center point here, the center vertical. Go from this corner to this corner and draw that diagonal out past the horizon line. Okay, and likewise on the other side. Then go from, and also keep this as concise as you possibly can. Don't have this line drifting back and forth. That'll be down the road, that will be a potential for causing some pretty big problems. So at this point, at least try to get all of these things as precise as you can. Take your time and really focus on this. And again, like all of the other exercises we've been doing, you know, give yourself a break if it messes up the first time. You'll have another chance to do it. But once we've got that, then we start taking, this ruler is not the best shape. Each of these points we're going to draw a diagonal line from that point to this point. Again, being as precise as we can. So we're going from here, and we are going to draw diagonals. Feel free to extend it out this way. We're going to connect those two dots. Take your time, be careful, line up these points. Keep your lines very, on the light side. I'm using a B for this one. This is one of those times that you might actually try using a bit of a harder pencil. You want your lines fairly light, because at a certain point we're probably going to erase, we're going to want to erase some of this stuff. So hopefully what this implies right from the very beginning is that all of your lines will converge at the vanishing point, except for verticals and horizontals. So those are the three basic elements that we're working with: verticals, horizontals, and diagonals. All of your diagonals, this is assuming we're making a little world of boxes, okay, which is what the plan is. All the diagonals move towards the vanishing point. All right. So hopefully we already begin to see what's happening here. Right. So now we're already seeing a plane receding into space, right? Which is essentially the function of linear perspective, is to attempt to move into space, and is to prepare ourselves for creating the illusion of three-dimensional depth on a two-dimensional surface. So hopefully we've got all of these lines as clear as we can possibly get them, as accurate, because now we want to line up these points where these diagonals intersect these diagonals. Those points right there. These are the ones that we want to make sure, and this probably want to be careful that we're not getting a tilt going on like this. But what we're essentially setting ourselves up for is that receding floor plane, this ground plane, moving back into space, now has tiles, for example, that are square tiles that begin to distort and converge as they move back into space. As well. Oops, that one slipped. Hold on. So theoretically we could keep going, but hopefully it's evident that they would just get getting smaller and smaller, and this gives us enough space to work in to start thinking about how we might start placing an object in that space. Now, the most basic object that we want to try to get a handle on is the square or the cube, and how does that element of the cube, that unit, how can we start to state the way that that operates in space. So right away we could assume that, for example, these four corners, these 4 points, represent what we could call the floor plan of our first cube. So at this point, I'm not gonna get totally relaxed to the point of having wobbly lines, but I am kind of trying to freehand a little more than I was up to this point. That you might be able to get away with that. So now we've got horizontals. We've got verticals. Let's maybe say that we're going to do again, I'm eyeballing this, but that's a good way of getting a rough measurement here. This length should be the same as this length, correct? And likewise up here. So that we now have the front face of the box, and the ground plane is receding. These diagonals are all receding off to the same vanishing point, likewise. So if that's the case, then we should also have these points also receding off to the vanishing point, however that might be. This is going to be another vertical. Somewhere in there it'll intersect at that point. This is going to be another vertical. This should be parallel with this. This should be parallel with this. Now again, this is a diagonal moving off towards the vanishing point. And again, towards the vanishing point. And again, here is our horizontal. So in very basic terms, this is the unit that we will work with for the next assignment, essentially. So you can kind of build anything in theory, any abstract thing in this, our little world, right? So you could build a tower, you could build a whole series of boxes in a row diminishing off into space. You could put a box floating up in the sky. Just the point that I want you to move towards is how do you begin to organize this space along the horizontal front, closer to the front plane? How do you move things back in space? How do you cut across space once you're back here? How can you transition? Maybe this is a high tower that moves up this way. How about we build a tower to start with, and we'll see where we go with that. So let's use that same unit again right here. So if this piece is occupying this ground plane, then we're essentially doing the same thing. But what I want you to do in the next case is, I might even grab this here, just so we're sure that we're a little bit more certain that we're going to get a correct 90-degree angle there. What I'm asking you to do here is run that tower across your horizon line. So now you're into this, you're crossing those two spaces of this lower area here, and you're moving across up into here. That may seem unimportant at the moment, but we'll see what happens here. All right. So now perhaps we will call, oops, let's say the tower is this high. Tower, column, whatever you want it to be, duct. Horizontal, vertical, vertical, horizontal, horizontal, diagonal moves towards vanishing point, diagonal moves towards vanishing point. Now you've got the front face, all of this piece right here. This front face of this rectangular form now. You want this side to fall back in space this way. So this then is on a diagonal. It has to move back towards the vanishing point, which is that. Likewise here. And if this is the intersecting point between this corner and this corner, then we want to connect here. So there may be a little bit of an optical illusion kind of going on there. It may at first be reading both interior and exterior. Are we looking at the top face of a box, or are we looking at the underside of the box? Now, what this means, the horizon line is our eye level. So if we're standing in flat planes, everything above here is going to be above our head. So it's all going to be moving down this way. Anything below that line is below our line of sight, right? So what we are looking at right here is the underside of a box. So if we open up the front of that box and we close the side, then we effectively have something like this, right? Whoa. Right? So this begins to imply where I'd like to go with this in terms of these objects are moving across this dimension and they're heading up to the upper dimension. So you're going to get this plane operating within the same object as you're getting this plane operating. I hope that makes sense. It's harder when there's nobody here actually asking me questions. But we can discuss this after. The other thing is you could have a closed object, or you could have an object that has the front open. Maybe this is a wardrobe or an open-ended box. This could go either way. This could be an opaque cube, or it could be a box that you're looking into, or it could be looking into this way. I hope that's a good starting point. I think we're going to stop there and take a look.